These are other types of sequences now in this question. Notice you will see Tn and N. What does that mean? N stands for a position number, not a term number. A term position number, not the actual term value. So if I were to do this first one manually, I just want to show you how that works. So, for example, I know term 1 is 2. In this sequence, term 2 is going to be term 1 plus that N value. That N value is that same value. It's a position number. It is not a particular term in the sequence. So term 1 is 2 and 2 plus 1 gives me 3. Term 3 is term 2 plus N, and N represents the term number. So I'm adding 2. That number and that number are the same. Now your calculator does this very easily. Term 2 is 3, plus 2 is 5, and so on. So let's see how we can set that up on the calculator now. First 6 terms we want. So Tn, so I've already got An, so I'm just going to delete that times 3, and then I want to add. Now to get N, you may have noticed it up here, that NaN bit at the top. It's not even a key, but it's NaN. Just tap that and you'll see N there. And then the first term is 2, and we generate the sequence. So you can see here, 2, 3, 5, thank God I've got them right, 2, 3, 5, and then it's the next 3, 8, 12, 17. We want the first 6. That's what it asks for in the question. So term 4 then, from the calculator, it tells us it's 8, 5, term 5 is 12, and term 6 is 17. So just slightly different. And then it did ask for the sum of the first 6 terms, which is 47. Reading that straight off here, S6 is 47 for that sequence. So I want you to practice the next one, part B, yourself now. Do it. So again, your first term is 5. We've typed in Tn, take 1, or An, obviously with the calculator you say. An, take N. So N is obtained up the top here. You tap on that where it says NaN to get N if you need it. By the way, I've just realised I didn't mention this. Sequences can be written recursively or explicitly. You'll notice this word explicit down here, which is also up on the screen over here. Now you'll look at that next year. So this year the focus for now is on just recursive sequences. And so make sure you're in recursive, not explicit. You'll know because it won't let you do Tn plus 1, Tn. So just keep that in mind. All right, so the start point, what happened there? I thought I had subtracted and changed this. It must have changed back. And there's your table. You can see 5, 4, 2, -1 are the ones I did, and then you've got -5 and -10, and then the sum of the 6 terms and we usually use S for sum, as I already mentioned, is -5. So there it is there. You could have taken those 6 terms and individually added them if you wanted to. Part C, bit different again. So this -1 to the power of N, again we're using N, not Tn, at least to start with. So I'll start this from scratch. How do we think we might type that in? As you see it really. So bracket, -1, close bracket, and then we want to do to the power of. And then you've got to go in here and tap in N. And then we want to times that by Tn. So back in there again to get your Tn. Check it, call up your table. Oops, except I forgot to change the first term, which is 7. Now you'll notice that there's something interesting about this particular sequence. It's got some interesting values. because we are literally just taking that number, or -1 to the power of the term value, term number, term position, probably better, -1 to the power of the term position, that is either going to be -1 if n is positive, if n is odd, or +1 if n is even. So you're just alternating between 1 and -1, and then depending on what an is will depend on whether your answer is positive or negative. So we're going to alternate. This is what we call an alternating sequence. We're alternating between positive and -7. However, notice that it's every second one, or every third, or two are the same and two are, then it changes. Two same, then it changes every time. So it's really quite an interesting setup. So I want you to think about why. Why does it go from 7, then you've got -7, 2 of them, then you're back to +7, 2 of them, then you're back to -7, 2 of them. It's quite an interesting scenario. Think about why that's occurring. That's your challenge. See if you can generate that sequence. Try that exact same one now. To me, why? Why is it set up in this way? If we look at term 2, term 2 is -1 to the power of 1 times term 1. So remember, when you've got n and n, they are the same figure. So if I'm dealing with term 1, then this needs to be the same value. And -1 to the power of 1 is just -1, and term 1 is 7. So there's your first -7. Then term 3 is going to be -1 squared times term 2. Now, -1 squared is positive, but this is negative. So positive times negative, there's your second negative. And then what's going to happen with term 4? Well, we've got -1 cubed, but term 3 is negative. -1 cubed is negative, term 3 is negative, and there you go back to positive. So that's why you're alternating each time. Well, not each time, but this alternates, -1, 1, -1, the next one will be +1, and then depending on whether that's positive or negative will depend on whether this one is positive or negative. So, too many positives and negatives. It doesn't matter. That's more for interest than anything else. As long as you can generate that sequence on your calculator. In a non-calc section, generally speaking, to be perfectly honest, it's all in context. So this is really more about calculated skill practice. That's it. In an exam situation, it should all be in a context that would make a bit more sense. And these alternating sequences rarely come up. It's more this kind of thing, say that kind of thing, but in an applied context that would come up. In fact, this is a first order linear recurrence relations. That's what we do. The other one's not. So, yeah. Just practicing on the calculator. That's the aim for today. All right, it sounds like we're done. So we'll leave it there for today, and I'll see you next week.